Hello students, this is fifth lecture, solid state. As already you have studied in previous lecture, the calculation of packing efficiency in simple cube, body centered cube and face centered cube. In this lecture, let us study the defects of solid, or it is also called imperfection in solids. There are mainly three types of defects: stoichiometric defect, non-stoichiometric defects, and impurity defects. You can see in this chart the classification is given: impurity defect, stoichiometric defect, non-stoichiometric defect. Stoichiometric defect again divided in four, that is Schottky defect, Frankel defect, and vacancy defect, interstitial defect, non-stoichiometric defect, metal excess defect, and metal deficiency defect. Stoichiometric defect: the compounds in which the number of cation and anions are exactly in the same ratio as represented by their chemical formula are called stoichiometric compounds. The defects that do not disturb the ratio of cations and anions are called stoichiometric defect. See, vacancy defect, interstitial defect, Schottky defect, and Frankel defect. Let us consider first vacancy defect. When some of the lattice sites are vacant, the crystal is said to have vacancy defect. This results in decrease in density of the substance because the entire space is vacant. This defect can also develop when a substance is heated. You can see in this figure vacancy defect, there is a site vacant. Next is interstitial defect. When some constituent particles, atoms, or molecules occupy an interstitial site, the crystal is said to have interstitial defect. This defect increases the density of substance. What happens? Here, the entire molecule or atom is not going to disappear, but it appears somewhere in other space, in the crystal itself. That is why the density of substance increases. Next is Schottky defect. It is actually a vacancy defect, but it causes vacancy of cation and anion both. That means equal number of cations and equal number of anions are entirely missing. It occurs in ionic compounds and also it decreases the density of solid. This defect is shown by ionic compound having similar size of cations and anions. It is actually the combination of vacancy defect and interstitial defect in the ionic compound. It arises when smaller ion is dislocated from its normal site and occupies an interstitial site. It is also known as dislocation defect. It does not change the density of solid shown by ionic compound having large differences in their constituent ion. For example, zinc sulfide, silver bromide, silver iodide, etc. Frankel defect. If an ion is missing from the correct lattice site causing a vacancy or a hole and occupy as interstitial site, electrically neutral as well as stoichiometry of the compounds are maintained. Here what happened? In Frankel defect, one of the ion or molecule or atom is missing from its original position, but it appears somewhere in the crystal lattice. This type of defect is called Frankel defect because cations are usually smaller. It is more common to find the cations occupying interstitial site. This type of defect is present in ionic compounds which have low coordination number and larger difference in size of cations and anions. Compounds having highly polarizing cation, easily polarizable anion. A few examples of ionic compounds exhibiting these defects are silver chloride, silver bromide, silver iodide, and zinc sulfide. Here, silver bromide is one substance which shows both Frankel defect as well as Schottky defect. Question may be asked for 1 mark. Name the substance or compound which shows both defect, that is Frankel defect as well as Schottky defect. Understood? Next, non-stoichiometric defect. As a result of imperfection, the ratio of number of cation and anion becomes different from that indicated by ideal chemical formula. The defects are called non-stoichiometric defect. These defects arise either due to excess of metal atom or non-metal atom or presence of impurities, foreign particles. As I told, there are two types. One is metal excess defect and metal deficiency defect. Let us say first metal excess defect. It has been observed that if a crystal of sodium chloride is heated in sodium vapor, it acquires a yellow color. This yellow color is due to the formation of non-stoichiometric compound of sodium chloride in which there is a slight excess of sodium ion. What happens in this case is that some sodium metal gets doped into sodium chloride crystal, which due to the crystal energy get ionized into Na plus and electron. This electron occupies a site that would otherwise be filled by chloride ion. So see here it is shown because of electron formation in the crystal, it occupies the space and hence it is known as metal excess defect, and the yellow color is due to sodium ion. Understand? Next one is metal deficiency defect. Here metal deficiency defect, in certain cases one of the positive ion is missing from its lattice site and the extra negative charge is balanced by some nearby metal ion acquiring two charges instead of one. There is evidently a deficiency of the metal ions, although the crystal as a whole is neutral. This type of defect is generally found amongst the compounds of transition metals which can exhibit variable valencies. You can see here in this figure, cations